What's up, you freaking geniuses? So in this video, I'm going to teach you all about compound interest. So I'm going to show you the formula, and then we're going to go over this word problem, which has several follow-up questions, so you know how to deal with the compounding on a case-by-case basis, all right? So first of all, this is the formula right here. So it's y is equal to p times 1 plus r over n raised to the n times t, okay? So y over here is your final amount. P is your principal, which is just your starting amount or your initial amount. Okay, R over here is the rate or interest rate, and that's always or normally going to be shown as a percentage in your word problem. But when we plug it into the formula, you first have to change it to a decimal, right? So that's really important. All right, and then N over here, this stands for the number of times that the interest is compounded per year, right? That's going to make a lot more sense in a minute. And then this N is the same thing. And then T over here just stands for your time, and this is always in years, okay? So now that you have the formula here, let's jump into this problem. So it says you deposit $420 into a shady offshore savings account that earns 6.9%, nice, annual interest compounded monthly. Write a function that represents the balance after T years. Okay. So we're going to use this formula right here, and then we're just basically going to plug some information in, okay? So here we're going to have y is equal to, all right, now what's our starting or principal amount? So that's going to be $420, right? So we're going to plug that in for p, and then we're going to have 1 plus r over n, okay? So what's r in this case? So r, again, is just the percentage. So here it's 6.9%, right? Now, remember, we have to turn this into a decimal first. So the way you do that is just divide this number by 100. Okay, so 6.9 divided by 100 is equal to 0.069, right? And then the easy way of doing that is just take your decimal and move it 2 times to the left. So then it's right there, and then you just put a 0 right there, okay? And so that's our rate, and then what's our n? Okay, so in other words, the number of times that the interest is compounded per year. Well, here it says that the annual interest is compounded monthly, okay? So how many months are in a year? Well, there's 12, right? So here we're going to have, well, first of all, let's write in our rate. So again, the rate was 0.069. And again, how many months are in a year? 12. So we have a 12 right here for n, okay? And then that's raised to the n times t. So we're going to have 12 times t, just like that, okay? Now we just need to simplify what's in our parentheses first. So first of all, we're going to do the division, right, because of PEMDAS. So 0.069 divided by 12, this is approximately equal to 0.006. Okay, so what we have in parentheses is actually 1 plus 0.006. So I'm going to rewrite this whole thing. So it's going to be y is equal to 420. And then in parentheses, again, we have 1 plus 0.006, which is equal to 1.006. And then raised to the 12t, okay? Raised to the 12t. All right, so this is the function that represents the balance after t years, right there, okay? Now let's jump into this first follow-up question. So it says, what will the balance be after 7 years? Okay, so remember, our time right here, right? The time for t is always in years. So if it's asking what will the balance be after 7 years, all we're going to do is plug in a 7 for t. But we're going to plug it into this formula that we just solved for, right? So we're going to say y is equal to 420 times 1.006 raised to the 12 times 7. Okay, and then we can simplify this further, right? So this is going to be equal to 420 times 1.006 raised to the 12 times 7 is 84, right? So we're going to have 84 right there. Okay, now 1.006 raised to the 84th power, that's equal to approximately 1.65, right? So here we have 420 times 1.65, right? And this is going to be approximately 694.20. Okay, so this is going to be our balance after 7 years. Okay, so not too bad, right? So now let's start changing how often our interest is compounded. All right, so B over here says write a function for interest that is compounded semi-annually. All right, so semi-annually just means twice a year or every 6 months, whichever way you want to think about it. Okay, so if we're going to write a function for this, it's going to be really similar to the one that we originally found up here. The only thing that's going to change is our n value. Okay, so remember the n value is this number down here and up here in the exponent. Okay, so in this case, the function would be y is equal to, so it's going to be 420. That's our principal. Then we're going to do 1 plus r over n. Okay, so the rate is still the same. It's still 6.9%. So it's still going to be 0.069. Now, what's our n in this case? Well, how many 6-month periods are there in a single year? 2 of them, right? So we're going to have a 2 right there. Okay, and then it's raised to the n times t, right? So then here we're going to have 2 times t. Okay, and I'll let you reduce what's inside of these parentheses if you want to make it a little bit cleaner. All right, let's go to the next one. So the next one says, what if it's compounded quarterly? All right, so quarterly means every 3 months. So how many 3-month periods are there in a single year? Well, there's 4 of them, right? So then here, the function would be y is equal to 420 times 1 plus 0.069 over 4. Raised to the 4 times t, okay? What if it was compounded weekly? Well, how many weeks are in a year? There's 52 weeks in a year, right? So then here, it would just be y is equal to 420 times 1 plus 0.069 over 52, okay? Raised to the 52 times t, right? What if it was compounded daily? Well, then this number over here, instead of rewriting it, I'm just going to borrow this one over here. Okay, so this number over here, let's see. So how many days are in a year? There's 365, right? So then we'd put 365 there and 365 there. Okay, now what if it was compounded continuously? This is the only kind of different one. So this one's actually going to be a completely different formula. So this one, we would have to use a formula that is A is equal to P times E to the RT, okay? So this formula, A over here is your final amount. P, again, is still your principal, so that's still the same. R over here is still the same. It's just your rate as a decimal. T is also the same. It's just your time in years. The only thing that's different here in this formula is this E number, okay? Now, E is kind of a special number. It's an irrational number, kind of like pi. So it's just like a decimal that goes on forever. And some people call it Euler's number. But in either case, E is approximately equal to, and I'll just write it over here, 2.71828. Okay, and then it keeps going. But this is what it's approximately equal to. Okay, and this is the formula you use whenever your problem says that the interest is compounding continuously. All right, this is the continuously compounding interest formula. Okay, so if we wanted to use it in this case, if we wanted to write a function, it would be A is equal to the principal, which is still the same, it's still 420, times E raised to the R times T. And then the rate is still the same, so it's still 0.069 times T. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.